Okay, so last class on Friday, we learned how to use the substitution method. So we learned how to isolate the weakest link, like look for the weak little antelope that only had a coefficient of 1 and get that one by itself. Can you let him in, please? Okay, never mind. Okay, and then we learned how to plug an equivalent expression in and solve for the variables one at a time. Okay, so we can solve for variables one at a time, but not two at a time. So if we can get rid of one of our variables, then we're like all good. So today we're going to learn an alternate method for getting rid of one of our variables. Remember how in Unit 6 we had different ways to solve that were easier depending on certain circumstances?
Yes.
That's going to be like what this is, but there aren't going to be a million ways. So we're just going to learn like substitution, elimination. We already did graphing, okay? There's just 3, okay? So today we're doing elimination. And it gets its name because we are going to eliminate one of the variables. Kind of makes sense. Okay, remember that when we test solutions, we have to determine whether each point makes each equation true. So if I put 4 and 1, the x and the y, in for equation 1, does 4 plus 1 add up to 5?
Yes.
Okay, so now we have to check equation 2. Okay, is 1 equal to 3 times 4 plus 1? No. So it is not a solution. Remember, it just takes one where it doesn't work to ruin the whole thing. Has to make both true. All right, let's look at B, the point 2, 3. This is our x, this is our y. So is 2 plus 3 equal to 5?
Yes.
Okay, what about is 3 equal to 3 times 2 plus 1? No. So it's not a solution. Just when you thought it was always going to be yes one and the other one no, sometimes they might both be no. Right?
Right.
Right. So it's important to show all those work steps. Any questions about testing solutions? All right, here we go. Now, you might remember from Friday that if we are going to try to solve an equation solve a system by testing individual solutions, that's a very inefficient method because we might never find the solution because there are infinitely many numbers, right? So we have to have other tools for solving systems. Now look at this one. Do you see that I don't have any coefficients that are 1?
No.
Right? None of them are 1. So if I were to try to rearrange this guy, here, I'll do it on here so that the people watching the video can see. If I were trying to rearrange one of these equations for y, it might be like this. Here's equation 1. 3y, don't write this, you'll be mad if you have to erase it. 3y equals negative 4x plus 16. Now to get y alone, I have to divide by 3, divide by 3, divide by 3. Look at all those fractions. Do we want to deal with that mess? Okay, it's not wrong, but is it nice? Is it easy? Is it friendly?
No.
No, it's gross. Okay? So substitution isn't always going to be the easiest method. The reason that we start with it is because I find that it's easier to understand what's happening. Okay? To me, elimination is the easier one to do, but it's a little bit like, ooh, a little bit smoke and mirrors. But now that you understand substitution, hopefully this makes sense. So, the cool thing about solving a system is that it is legal to add the equations together. So after doing a mystery step that we don't have to do on this problem because it's already done, we are going to add the equations together. Now, why would we want to do that? What do you think happens when we add these together? Well, 4x plus 2x makes 6x. Look what happens to the y's. Yeah, they're eliminated, which is the name of the method, right? Okay, so we didn't even have to do any of that gnarly substitution with all the fractions. We can just add the equations together and say goodbye to the y's. Boom. 16 plus 8 is 24. Can you divide by 6 in your heads? X is 4. Okay, so we solved for x. Now we just have to substitute and solve again. So from now on, it's just like yesterday's review. So we put in the x to our favorite equation, and we solve for the y. Which one do you like the look of? Second one? Okay, here's equation 2. It does not matter. You just pick the one that's friendliest to you. So it says 2 times x, which is 4 now, we know, minus 3y equals 8. Okay, what's 2 times 4? 8. Okay, everybody okay if I subtract 8 from both sides? Okay, I get a 0 on the right, and I get a negative 3y on the left. How do I undo multiplying by negative 3? Yeah, divide both sides by negative 3. And I get y is 0. And that's the other part of my answer. So my answer is 4, 0, where the 4 is the x and the y is the 0. So we substitute and solve again. Yeah. Yep. I would go fast. You don't want to miss much of this next part. All right, now, sometimes the math gods smile on us and they give us things like this where the 3y and the negative 3y automatically cancel. And we just say, thank you, math gods, and we keep it moving. However, sometimes they're a little bit more feisty. Look at this. Right now, there's nothing to stop me from adding these two equations together. It's totally legal, but will it cancel anything? No, so not helpful. Okay. Now, can you think of anything we could do to turn a 2 into a 3 or a 3 into a 6? Yeah, if we multiply by 2, we can get a 3 turned into a 6. Does everybody see that?
Yeah.
And then we can cancel. So that's what we're going to do. We're going to multiply our first equation by 2. So I'm going to multiply both sides by 2. Remember, that's the multiplication property of equality. It's totally legal. We've been doing it since the beginning of the year. 4x minus 6y equals 30. Now I'm going to rewrite my equation 2 just so they're nice and neat and stacked. 3x plus 6y equals negative 9. Now I'm ready to add my equations together. I'm getting 7x. My y's cancel. And 30 minus 9 is 21. Can you tell in your heads what x is? Okay. Okay. Now we're ready to substitute in for x and find y. So pick your favorite equation. Number 1? Oh, second one? Okay, weird. No, I guess that's okay. Okay, so 3 times 3, make sure you plug in the right thing, plus 6y equals negative 9. Okay, 3 times 3 is 9. So I'm going to subtract away 9 from both sides. That gives me 6y equals negative 18. Divide both sides by 6. Negative 3. Okay, so make sure you write your points in the correct order. It should be 3, negative 3. That's it. What do you think? Okay, it's time to level up. Okay, look at these nasty coefficients. Ugh. Yuck. Okay, this makes us happy though, because the nastier our coefficients are, the better this problem is for elimination. Okay, so can you think of anything we can do to multiply and turn a 3 into a 4?
No.
Or a 3 into a 5? No. Okay, so at this point, we can't just like multiply by 2 or something cute like that. That works sometimes, but not all the time. So if we can't turn a 3 into a 4 or a 5, we have to pick whether we want to focus on the x's or the y's. So since we eliminated the y's twice on the front, let's do the x's on the back so that you can see that you can eliminate either. All right, so I'm focused on the x's. I can't turn them into a 3 or a 4, but could I turn them both into 12?
Yeah.
Ha. So what would I have to do to turn the first 3x into a 12? Yeah, but I'm going to have to multiply the whole equation by 4 because of the multiplication POE, right? So I'm going to multiply this whole thing by 4, which incidentally is this coefficient. You see that? Okay. And then what do I have to multiply the other one by? 3. Now, if I have 12x and 12x, do they cancel yet? No. So I have to make one of them negative. Boom. So we're going to multiply the first one by 4 and the other one by negative 3. It doesn't matter which one you make negative mathematically. I try to pick the one to make negative that already has negatives in it, because when I multiply by negatives, a negative by a negative, I get positive, and I'll have fewer negatives overall. Does that seem like a good strategy? Okay. But it really works either way. It's just nicer if you can remember. So 4 times 3x is 12x. 4 times 5y is 20y. 4 times 2 is 8. Okay, I'm going to write the other one right underneath it and stack it. Hey, don't fall asleep. Write this down. Okay, negative 12x. Negative 9y. Negative 3 times negative 1 is positive 3. Now we're ready to add. Okay, and this time we are going to solve for y first, because the x's are about to go away. So 12x minus 12x, 0 x's. 20y minus 9y, 11y equals 11. So what's y? Good. All right, pick your favorite, most friendly equation. We always plug back into our original equation, just in case we made any algebra mistakes by rearranging. Which one? First one? Okay, so that one was 3x plus 5 times y, which is 1. We know that now, equals 2. So I know that 5 times 1 is 5. So I'm going to subtract away 5 from both sides. And I get 3x equals negative 3, and therefore x is negative 1. Now we found the y first, but we still have to write the x first in our point. So we always put the x first, even if we find it second. And it helps me to label them because if I did it wrong, my eye will catch it more likely if I label. Mm-hmm. Yep. Okay, any questions about that one? Okay, this next one isn't any harder. It's just the same, just to make sure we've got it. All right, here goes nothing. So, can we turn a 3 into a 2 or a 7 into an 8? No. So we're going to have to multiply both equations. Okay, so the first one we're going to multiply by a 2. And then the second one we're going to multiply by a 3. And then we have to pick one of them to be negative. Okay, I like it. Now, does everybody see that if we had decided to cancel the y's, because the y's are already opposite, we wouldn't have had to pick one to be negative because it was already negative? You see what I mean?
Yeah.
Okay, perfect. But we would have had to multiply by 7 and 8, and no one wants to do that, so this is better, I think. All right, so 6x plus 16y equals 4. What? She's over in 209. Thank you. Negative 6x positive 21y equals positive 33. Okay, now we're ready to add. Okay, my x's go away. They are eliminated by the elimination method. 16y and 21y make 37y. And I get 37 on the other side too. So what's y? Yeah, 1. Okay, we solved for y. Now we're going to substitute that in and solve for x. So I like the look of equation 1. What about you guys?
Yeah.
Okay. 3 times x plus 8 times 1 equals 2. I know that 8 times 1 is 8. So I'm going to subtract 8 from both sides. And I get 3x equals negative 6. So my x is negative 2. Whoop, whoop. All right, we're almost done. We're just going to do a word problem. We're going to do more word problems tomorrow, but if we do it over 2 days, it's easier. And then tomorrow will be a walk in the park. All right. So, Chuck's Chocolates sells M&Ms for $2 per ounce and pecans for $3.50 an ounce. Chuck wants to make a 12-ounce mix of M&Ms and pecans, and he's going to sell it for $30. So our job, we've got a couple of jobs. We have to define our variables. We're going to write a system of linear equations for the whole problem, and then we're going to solve it to answer this question. Now, remember that the question is going to tell us what the variables are. So what are our 2 unknowns? Remember, we get 2 variables. We don't know the It says how many ounces of M&Ms and pecans should go in the mix? Yeah, we don't know the ounces. So there are two types of ounces we don't know. We don't know ounces of M&Ms, and we don't know ounces of pecans. So we could use an X and Y, but honestly, if I use X and Y, sometimes I get confused on what I make X and what I make Y. So I'm going to use M and P because it's a little bit more teacher proof. Okay, so I'm going to say M equals ounces of M&Ms. Don't say individual M&Ms because you'll lose points for that. Okay, and I'm going to say that P is ounces of pecans. You will not lose points if you say X and Y. I just find it easier at the end when I'm deciding what meant what to use letters that make sense with the problem. All right, now we're going to go through and see if we can find the two totals. Do you see a total? Okay, so one total is $30. Okay, what's the other one? 12 ounces. Okay, so the equation types that we're going to write look like this. AX plus BY equals C, where the constants are going to be the totals. Okay, so we're going to write two equations like that. So I'm going to have a 30 for my total. That's my money equation. And then I'm going to have another one where my total is 12. Because I'm going to add up a bunch of stuff and set it equal to a total. Okay, Cole, tell me what you were saying about the money.
$2 per ounce of M&Ms.
Yeah, we got $2 per every ounce of M&Ms. So does everyone see that I could write that as 2M? Okay, plus how much for every ounce of pecans? $3.50. There's one. Now the other one is simpler but harder at the same time. What has to add up to 12? This is total ounces. So the ounces of M&Ms and the ounces of pecans, which are just M and P. Okay, so it's so simple, it's kind of like hard for kids sometimes because they just stare at it because there aren't any more numbers. They're trying to look for numbers and they don't see any because the coefficients are just 1 and 1. You see what I mean? Okay, go. You're welcome. Now, we defined variables. We have a system. We're ready to solve. Would you like to solve this using the elimination method that we used today or the substitution method that we used yesterday? Okay, so do you see that this has coefficients of 1, which are easy to get alone? So this is a good candidate for substitution or elimination. Cool? Okay, let's do it. All right. So I want you to look into your future. If you plug in for M, you'll have to distribute a 2, right? If you plug in for P, you'll have to distribute 3.5. Which one would be easier?
2.
Right. So what do you want to solve for, M or P? M. Will they both work? Yes, but M will be easy and P will make you want to cry a little bit. Okay? So choose the easy adventure. So I'm going to subtract away P from both sides. Now I have an expression that's equal to M, 12 minus P. So I'm going to plug it in for this M right here. So that gives me 2 times 12 minus P plus 3.5 P equals 30. Okay, and as promised, nice and easy, we'll distribute the 2. That gives me 24 minus 2p plus 3.5p is 30. I've got 2 things happening right here. I've got a 24 to subtract away, and I've got some like terms to combine. Are you guys okay if I do it in one step?
Yeah.
All right, hold on to your hats. Okay, so if I combine my p's,
You get
1.5p. Okay, now I'm also here, I'll do this in another color. I'm also subtracting away my 24. So I get my 1.5p equals, what is that, 6?
Yeah.
So divide both sides by 1.5 and you get?
4.
Yep. Now, what do p and m have to add up to? Yeah, so what's m? Ivan's got it. What plus 4 is 12?
8.
8, right? Okay. M is 8. All right, so now we just have to write a sentence. So, the mix needs 4 ounces of pecans and 8 ounces of M&Ms. Guys, that's it.